Okay, so onward we go here. This is 1.46. This is for the two vectors in E1.35. Find the magnitude and direction of the vector product and the vector product the other way. So we have vector A is, well, we got to figure that out, but it's going to be equal to the magnitude of the vector times the cosine of 60 degrees times I hat plus the magnitude of the vector times the sine of 60 degrees times j hat. And that's because if you look at the figure, the angle here is between the x-axis and the vector, so the adjacent side of the right triangle that you would form is the x component, and the opposite side is the j component. So that's how that works out. So if you get 2.8 times the cosine of 60, which is 1.4, so you get positive 1.4 I hat plus 2.8 times the sine 60, which is going to be 2.42. 2.42 j hat. And I guess, we have the units in centimeters. I can put this out, centimeters outside. The B vector is in the fourth quadrant, so you're going to have positive x and negative y. So we have positive x. We have the magnitude, which is 1.9 centimeters times, in this case, the adjacent side to that angle is the x component. So we're going to again have the cosine of 60 degrees I hat, the unit vector in the I direction, or the x direction, 1.90 centimeters. And then this is going to be negative because we could actually either put this negative and say it's the sine of 60 degrees, or we could say it's positive the sine of negative 60 degrees, which would give us the right sign anyway. Okay, so 1.9 times cosine of 60 is 0.95. And then we have a negative 1.9 times the cosine times the sine of 60 degrees, which is negative it's 1.65, but it's negative because of this negative sign, j hat. So those are the vector forms of those two vectors. So what they want is A cross B vector, A cross vector B, and the way we do that is we set up this 3 by 3 determinant. We have I, J, K. The A vector is 1.4, and let me go ahead and put centimeters down here. We'll leave the units out, but we'll just have units as centimeters because it's going to be a vector, so we're not squaring anything here. Okay, so A is 1.4, 2.42, 0, 0.95, negative 1.65, 0. And if you remember the previous one we did, the only one that actually is non-zero result is this K vector. So the result is going to be the unit vector K times the submatrix here, the 2 by 2, subdeterminant. And the way we do that calculation is you take this times that minus that times that. So it's 1.4 times negative 1.65 minus 2.42 times 0.95. So 1.4 times negative 1.65 minus 2.42 times 0.95 is negative 4.61k. So that's the cross product, or the vector product. Now, the only thing that's going to happen is if we do A, B cross A, is we're just going to switch the rows here. So this becomes 0.95, negative 1.65, 0, 1.4, 2.42, 0. We still only have the k unit vector. But what we'll have, and we'll get the same magnitude. The only difference is going to be the sign. You'll get 4.61k. So the order of cross product makes a difference. It doesn't make a difference in your answer, except you could change the sign. And if you had I, J, and K components, they would all change sign. So you can see what's happening is 0.95 times 2.42 minus a negative 1.65 times 1.42. So we're multiplying the same numbers together. We just, this one we had this times that minus that times that. Here we have this times that minus that times that. So you get positive. So I'm just checking the answer here. Actually, that one's not on the back of the book. So you just have to believe me that I did it right. Okay, the next one. For the two vectors AD given in 124, find the magnitude and direction of the vector product. Same thing. Okay, so 1.47. We already did the, on a previous problem, we did the components. So if you want to go back and look at problem 143, so I'm going to stop here for just a second because I'm going to go find what it is instead of having to do it over again. So let me stop the recording. Okay, so those are the vectors that I got from the other one. So A cross D. We already know that all we have to do is change the sign from the first part, so we don't have to do it again. We already know something. We don't need to discover it again. So as you remember, if you change the order of the cross product, you just change the sign of the component. So A is 0, negative 8, 0. D is negative 8, 6, 0. So the only one we have is the K component. So it's going to be K times the matrix 0, negative 8, negative 8, 6. And we take 0 times 6 minus this. So you'll get this times that's 64. Then you have a negative sign because it's this diagonal. So it's going to be negative 64K. Therefore, vector D cross vector A, D cross A is positive 64K. Okay. So let's see what we got here. 147. Yeah, they have negative 63.9 because I rounded off those things. So 147 says negative 64, and they have meters squared. And 64. Actually, they do square the units because these do have units, which I didn't do over here. I guess this one has units of meters. So when you multiply these things together, you do get the resulting cross product. It is a vector, but the units are meters squared, whereas the original units are meters. So this is b meters squared, this is b meters squared. Okay, final one, 148. And the vectors in 1.39, which I don't think we actually done that previously. So we're going to have to take the vectors in problem 139. So we have, and make them into the component vectors. So The angle 70 degrees shown there is between the x-axis and the vector. So the x component is going to be the magnitude, 3.60 meters, times the cosine of 70 degrees times the unit vector in the x direction. And then you take the magnitude times the sine of 70 degrees times j. So our a vector is 3.6 times the cosine of 70 degrees is 1.23 I hat plus 3.6 times the sine of 70 degrees, which should be a bigger number, which is 3.38 j. And the b vector is in the third quadrant, so they're going to be both negative. So you'll have negative the magnitude, which is 2. Oh, I forgot the units again. So let's just put those there, meters. Okay, so you get 2.4 times the cosine of 30 degrees times I hat, and we got to put the meters in there. And then the second one is negative 2.4 meters times the sine of 30 degrees times the j vector. And so we get 2.4 times cosine of 30, which is negative 2.08 I hat minus, we take 2.4 times the sine of 30, which is a half, so we get 1.2, so you get negative 1.2, put 0 there, j hat. Okay, so that's the b vector in the third quadrant. This is a vector in the first quadrant. So the cross product of a cross b, actually what they want to find is they want you to find the dot product of those two vectors. So a dot b, so vector a is 1.23 meters I plus 3.38 meters j. And we're going to dot that with the b vector, and the b vector is negative 2.08 I minus 1.20 j. Those have meters in them. Meters j. So it's a scalar product, but you do have the units squared again. So you're going to have 1.23 times negative 2.08, which will give you negative 2.56 meters squared. So that's from this times that. And then we have another one, which is 3.38 times 1.20. They're both negative. Oh, wait a second. No, this is positive. This is negative. So you end up with a negative result again, which is negative 4.06 meters squared. So then you add the two terms together, and you get negative 6.62 meters squared. And because that's negative, we know that this angle has to be greater than 90 degrees. If you look at the figure in page 29, you'll see that the angle is greater than 90 degrees. The denominator, in the equation, the cosine of phi is equal to a dot b divided by the magnitudes. The magnitudes are always positive. So since the denominator is always positive, the sign of the numerator gives you an idea of whether it's greater than or less than 90 degrees. And because it's negative, we know it's greater than 90 degrees. Okay. And then we have a cross b. So we set up our determinant. And the next, so a is 1.23 meters, 3.38 meters Here's 0. We don't have any k. And then we have negative 2.08 meters and negative 1.20 meters and 0. And so when we break this out, again, the I and j don't give us anything because we're going to end up with this column in both cases. So all we have is the k vector. And then we do this submatrix here, this one involving just numbers. So we end up with 1.23 meters times negative 1.20 meters. And then we subtract the product in the other direction, which is 3.38 meters times negative 2.08 meters. And we multiply those out, we get 1.23 times negative 1.2 minus 3.38 times negative 2.08, and we get 5.6 k, which is a vector. And the other thing about cross products is that the resultant vector is always perpendicular to both the other two vectors, or to the original vector. So the original vector is in the ij plane, which is in the plane of the screen here. Therefore, k is perpendicular to that. So it either points out or points in. Because this is positive, it means it points out towards you, if we define out being positive.